Hello and welcome to our presentation for FireDrone, an autonomous wildfire detection system. Accurately detecting small forest fires is challenging and time-consuming. Annual wildfire management costs in Canada are increasing, and surveying for forest fires covers limited areas, employs an inefficient use of manpower, and often requires the costly operation of aircraft.
From our initial stakeholder consultation, we identified current wildfire detection methods as well as requirements and needs that we would have to consider. We came up with FireDrone. FireDrone is a drone module and software platform designed to address our stakeholder needs and increase forest fire detection efficiency.
We selected the Raspberry Pi 4 BN880 GPS, Raspberry Pi wide-angle camera, and a battery for our design. Infrared was not used due to cost. The front end uses React, the back end uses Node.js, and the server is hosted by Heroku. Image processing uses TensorFlow.
The user implementation for FireDrone is as follows. The drone is given a flight path and a geofence scouting area. Then, the FireDrone module is activated and the drone is sent out. FireDrone then takes photos at a regular interval and analyzes them. It either does not detect fire or it detects smoke. Then it takes and sends photos and GPS coordinates to the server. The fire technician is alerted, reviews images, fills out the IFR form, and makes further decisions.
3D printed cases hold the Raspberry Pi and GPS. The Raspberry Pi case has a vent for passive cooling. The camera and battery are also held by secured plastic cases. This is an example implementation of our device on the Applied Aeronautics Albatross UAV, an inexpensive long-range drone approved for beyond visual line-of-sight operation in Canada.
Here we can see the GPS operational and displaying data in the console. It includes speed, longitude, latitude, and altitude. This video shows the camera preview, showing the Raspberry Pi and GPS module. It then takes a picture that is stored in a folder accessible by the Object Detection program.
There are 3 scripts running on the Raspberry Pi in parallel. They communicate with each other via pipelines, and data is streamed from the camera and GPS module to the Raspberry Pi. The Raspberry Pi sends data to the web server hosted on Heroku, which appends the data into the MongoDB database. This is how the documents on our MongoDB database is structured. We have initial fire reports, sensor alerts, photo collections, and users.
As you can see on the following slide, the dashboard is a data summary of all our information, most important of which is the fire alert summary, which pictures the most recent alerts as well as our most important information.
This is what the gallery page looks like on our website. Each individual fire has its own gallery of photos, so the user can quickly navigate through all the photos associated to a specific fire.
A key feature of our web platform is the ability to easily create an IFR form. Not only is some of the information automatically filled out based on what we receive from the Raspberry Pi, we've also broken down the IFR form into simple steps so that it's easier for rangers to fill out.
We decided to include a map on our website so our users can easily visualize where the fires are located. Each fire is displayed on the map with a fire icon, and the color of that icon depends on the current fire status.
This video demonstrates the smoke detection program running on the Raspberry Pi. This image was just taken by our camera. If smoke detected is printed to the console, and the labeled results image is saved to be uploaded to the server. Our image detection model was created by training the efficient depth model on a custom dataset of smoke images from aircraft and watchtowers. On a test set of 191 images, our model accurately identified smoke from wildfires 86% of the time, with an average confidence of 90%. Shown here is a summary of the results images from our model.
Thank you for listening to our presentation on FireDrone.